All right. Yeah, do we want to be doing all this? Maybe. We're going to be coming into this later, so we might as well. So when we get into the next topic, we'll be non-determinist, we'll be finite state determinist, and then we'll kind of be focusing on languages that say yes or no. All right, so let's just review a computational problem, right? It's given an input I, and there's some required output, and this machine is a set of instructions that solves it. We did this already, right? Given an input, it outputs something, or runs forever. Say we say M computes P. If for every input it stops and gives the right answer. A language is a yes/no problem. And so we'll draw pictures like this. This is a set of all inputs, and the ones in here are the yes instances, right? The square is the set of all instances. Those are the ones for which the Turing machine says yes. The answer, required answer is yes. And so the language is the set of all binary strings for which the answer is yes. We'll be using that notation. The guys out here are the no instances. So we have a machine that given on input I outputs something, and we say the language, right? Which language is in computing on? It's the inputs for which the machine stops and says yes. Right, so a machine is a little complication, is the machine can halt and say yes, or can halt and say no, in which case it's clear that the answer is yes or the answer is no. But the machine could also run forever, in which case we'll default and say the answer is no. And the purpose of the Turing machine is to discern between the yes answers and the no answers. Right? So I guess this type of machine discerns between yeses and nos, because on yeses it halts and says yes, and on no's it either halts and says no or it runs forever. But that's when a machine decides, this is, let's see, let's see. If it recognizes, so that's, when it recognizes or accepts it could run forever. But when it computes it or decides it, it always has to halt. So those are the difference between recognizable, acceptable languages versus what things that you decide. You have to always say yes. Stop, you always have to halt. So we have these various complexity classes, right? This is the set of all problems for which there's a Turing machine that decides them. And that's the set of ones for which you can run in exponential time versus the ones that you run in polytime versus the ones that have a non-deterministic polynomial time algorithm versus their complement. And then up here, these are the ones that are recognizable, meaning when it's a yes instance, they have to halt and say yes, but if it's a no instance, they could run forever, and their complements. So this is just a quick review of that's it for that.